We're working on the least common denominators today, or the LCD, and you've done this before like usual. Again, we're just taking it a step up by doing some factoring and putting some variables in here. But basically, I've given you guys a goal, and basically your goal is you need to get the denominators to be exactly the same. That's pretty much what's going on. And to be able to get the least common denominator, you want to get one of each thing that's being presented to you, in the denominators at least. And remember that whatever you do to the bottom, you're going to need to do to the top eventually. Okay, so let's go ahead and let's just start working on some examples here. I have, for the first set of problems, I am asking you to find the least common denominator. And so just like what we did yesterday, the first thing I would recommend is to factor if you can. So for this first fraction here in number 1, obviously the 3 on the top, hopefully you know you wouldn't factor. There's nothing really to factor it into. But on the bottom, I can pull out a 6, and I'm left with this. Okay. For number 1, here on the second fraction, the 8, is it going to stay the same? But on the bottom, I have this. Okay, so once you get to the step where you've gotten, since all I'm asking for is just for the lowest common denominator, or the least common denominator, what you're going to do to be able to decipher this is watch my pen here. Here's my cursor right here. What you're going to do is let's go ahead and circle this lightly, the denominators, both of the denominators that we have. And our goal right now is we want to get one of everything without repeats. So if I'm looking at this, I have a 6, I have an x minus 5, and I have a 9. And then I see x minus 5 again, but I already wrote it down, so don't worry about that. What I want to show you right now is how to figure out what the LCD is between numbers. So the x minus 5 is for sure going to be there because it's the only thing that we have right now. Oops. Okay, so x minus 5 is okay, it's staying. But the 6 and the 9, we're going to need to find the LCD between those two. So when you just have regular numbers with no variables attached, just like how the 6 and the 9 are, this is how you'd find the LCD. So let's break this into a factor tree, both of them. And so we want to get them into prime numbers. So we have a 3 and a 2 for 6, and then a 3 and a 3. And we're going to repeat that same step we just did, where we took one of everything, except we're going to do it with the prime numbers we have in the tree. So for the 6 gives me a 3, and it also gives me a 2. The 9 gives me a 3, actually gives me 2 3s, which I've already written down here. Okay, so the numbers are a little tricky, but watch me here. So I've broken them into primes. I want one of each number now. So I got a 3, I've got a 2, and then I have 2 more 3s here, but I already wrote down a 3, so I don't need to write any more extra. And now what you want to do is look at these numbers. So on the tree with this, on the 6 tree, basically I have 1 3 and 1 2. And then on the 9 tree, I have 2 3s, which is going to factor further if you wanted to make it a little simpler, 3 squared. Okay? Now, looking at the trees, which one has a bigger 3 exponent? Is it the 6 tree or the 9? The 9 tree has one. So once you've factored the regular numbers just into a factor tree and gotten them into primes, and you've written down one of each number, you want to look and see which one has the biggest exponent. So in this case, this 3 has the biggest exponent, so I'm going to put a little 2 there. And in this one, the only choice for 2 is on the 6 tree, and so that's it. There's nothing to choose from there. It's going to be just regular 2. Last thing you want to do here is just multiply everything you have. So 3 squared turns into 9. The 2 is there. And then remember we had that x minus 5 that we brought down a long time ago. So my final LCD for this is 18 x minus 5. Okay. So the number part is a little weird, huh? You would think that would be the easy part, but it gets a little weird. So let's look at number 2, and let me draw a line here so that we know this is 2 separate problems. Okay, let's try number 2 and do the same thing. So for number 2, 15 stays, But on the bottom, this 4k minus 6, I can pull out a 2. And what's left inside is a 2k minus 3. Okay, I drop that and down. In the second fraction, 12 stays. I have a 6k minus 9, so I can pull out a 3 that they have in common. Okay, so, 2k minus 3, I'm sorry. Right back there. So if I pull out a 3 from that second one, I'm left with a 2k minus 3. Alright, here we go. So what I want to do again, since I'm just finding the LCD, I'm not worried about the numerators right now because all I'm trying to do is just get you used to getting the denominator part of it. So let's circle this lightly, both denominators. Remember, first step is I need one of each thing here. So I have a 2, I have a 2k minus 3, and I have a 3. Okay? So for sure the 2k minus 3 is going to drop down into the final answer. So you don't have to worry about that, but it's the numbers again. But what's better about these numbers is that they're prime already. So even if I made the tree, it's like 2 and 1 and 3 and 1. Since they're prime, it's not going to be as weird as the first example. So all you do is you want one of each thing. So you want 1, 2. You want 1, 3. Check the trees, so the biggest exponent for 2 is just this guy, just that 2 to the first, so I leave it. For the 3, the only 3 is this one, which is 3 to the first, so I leave it. So my final LCD for this is 2k minus 3 times 6. So the 6 should go in the front, it's a little bit better there. Alright, so hopefully this is getting a little bit okay with the lowest common denominator. What I want to show you guys right now is I want to show you how to do this when we're fixing the numerator now. Okay, so the directions for this is I want to rewrite the fractions with their LCDs. So just like what we did in 1 and 2, we're doing something similar, but I'm going to show you how to change the numerators now. We're not just finding the lowest common or the least common denominator. So number 3, 9 stays. Okay, but what do we have here on the bottom? We have to factor, so maybe let's go 1 and 1, 4 and 4 maybe, and remember, because this is a plus sign in the back, when I factor this, the signs are going to be the same. How do you know which sign to use? Go to this first sign, minus, minus, okay, and we're adding the products now to get the middle number. So 1 times 4 is 4. 1 times 4 is 4. If you add those, you get 8. Alright, so they match up. Very good. And then remember, you group going across. So one's grouping is going to be x minus 4. The other one's going to be x minus 4. Okay. And then we have and. Let's do the same thing here. Keep that 5 there. Let's see. So same idea here. Since my back sign is a plus, that tells me both of the signs in this final thing is going to be the same. Which sign? It's going to be a minus. Again, it's minus because I have first sign is minus up there. So let's go ahead and factor that second part. I'm trying to make some room here, so I'm erasing this in the corner. Alright, so the x squared, the number in front of x squared for that second fraction is 1. So that makes it a little easy. So I have 1 and 1. For 12, let's try 4 and 3. Remember, because my back sign is a plus, we're going to be adding to get the middle number. If I add those two, do I get the middle? I do first try. I'm getting good at this. So we go 1 and 4 get grouped together, 1 and 3 get grouped together. So here's what I have. And I want to write this a little bit better here, so let's write this like this. 9. Okay, so all I did here was, instead of writing x minus 4 twice like that, I just put a little squared. And so let's do this again, same idea here. We want to get one of each number in the denominator. So I have x minus 4 I have an x minus 4 again on the other one, and an x minus 3. Okay. But what's different about this now is that for the x minus 4s, there's not just one of them. You're going to treat them just like what we did on the previous for number 1. Looking at this, what's the biggest exponent you see in the denominators for x minus 4? So I'm trying to circle it to help you. Biggest exponent you see for the x minus 4. You see 2, right? So what's the difference with this is that for the ones we were doing in 1 and 2, see how in 1 and 2 there was just an x minus 5, that was the only thing there. There was just 1 and 1 on each side. Same with this one, 2k minus 3, there was just 1 and 1. There was no exponent to choose from. In number 3, there's 2 x minus 4s here, so it turned into an x squared. So what you want to do is, if that's the case where you have more than 1 underneath one fraction, you need to take that into account and see that. So you take that, the biggest exponent you have, and it gets attached to that in the final LCD there. Okay, so the common, the x minus 3, there's just one of them, so you don't have a choice to choose from whether you want the squared or just one of them. So the x minus 3 just drops down, just like how I wrote it. So the way that you do this is, the point is that I want you to show you guys how to do this with the numerators. And so the LCD for this is going to be x minus 4 squared, because that's the x minus 4, the biggest exponent you have for x minus 4 is squared, and then times x minus 3. Remember, you want one of everything, and you want the most of that everything. Okay, so looking at this, this first fraction had a 9 originally. What did I do to make it different? So how is this blue one different from the brown one, the new one? So it has the x minus 4 squared, which is good, but I put an x minus 3 in there. I'm multiplying an x minus 3. So if I multiply an x minus 3 to the bottom, that means I have to do that to the top too. So I have a 9 times x minus 3. Okay, for this one, for the second fraction, I have an x minus 4, excuse me, times x minus 3. So what does this one have that's different? It has an extra x minus 4, right? This one is just a regular x minus 4. The new and improved LCD one is an x minus 4 squared. So what that means is that for me to get the LCD, I had to multiply another x minus 4 there, which means if I did that on the bottom, I had to do that on the top. So what I have is that. Okay, so my two fractions, what I'm going to end up having, rewriting the fractions with their LCDs, is going to be this. Okay, that's my answer for this. So that's how you would take care of the numerators. You would just see what's different from what you had to multiply extra, and you multiply that to the top pretty much. That's a little weird, I know. Let's try number 4 and let's see. So the 5 doesn't factor, and the bottom I helped you out already. They're already factored there. So it looks like that. The bottom, or sorry, the second fraction, negative 3 stays. This one I gotta factor though, so 1 and 1, 2 and 2, we're adding. Oops. So yep, I do get the middle number here and here. So we get x plus 2, x plus 2. Again, the signs are the same because this back sign is a plus. Which sign do you take? You look at the first sign, so they have to be plus plus, and then you group them going across. Okay. Looking at the denominators, you want one of, actually let's rewrite that one. So 5 x plus 2 times x plus 3. This one's going to be x plus 2 squared. Okay. So what are you going to do now? You take one of each denominator, which would be, I see an x plus 2. I see an x plus 3. So let's write that in here. Okay. This one has an x plus 2 again, but it's squared. So once I see that squared, or once I see something bigger, I have to take that bigger exponent. So this was just 1x plus 2. This one is a squared, so there's two of them. So I gotta observe the biggest one that I find. So I put a little 2 there. Okay, so one of everything, but if you find more of it, remember you want to get the most you can possibly get. So you want to take the bigger one. Okay, and so my final LCD for this is going to be x plus 2 squared times x plus 3. So you got one of everything and you got the biggest of what you could get. X plus 3, there's only one x plus 3 here. So you can't square it or anything because it's the only one that you can have to pick from. So let's write both of our fractions here, get them started with the LCD. Okay. And so what do you want to do? Let's see what was different here. So the 5 on the first fraction was there from the get-go. Sorry, I'm using two different colors on this. Just want to show you the difference. So what's the difference here between these two denominators? What's extra? What's extra is that I had to multiply another x plus 2 to the new denominator. So if I do that on the bottom, I have to do that on the top. Okay, let's look at this one. So the negative 3 was already there. And so the extra thing I had to tack onto it was that x plus 3. So if I do that on the bottom, I have to do that on the top. And so there you go. And it looks like that. Okay, so final answer for this is that. Okay, so it's a little weird, I know it's really strange and it's kind of difficult, but we'll practice with them, see how you guys do when you take this, and you answer the questions for tonight, and we'll go over them in class tomorrow. Okay, so write down your questions. Remember, you want one of everything in the denominator, and you want to take the highest exponent you could possibly get of the stuff. So if it's numbers, break it down into prime numbers, just like I did in numbers 1 and 2. And then examples 1 and 2, break them down into the prime numbers. Let me bring that over here, like I did here. So you have a 3, you have a 2. I'm here, number 1. You have a 3 and you have a 2. You have a 3 again, but oh, I could get a 3 squared. I want the most I could get. I'm greedy, so I'm going to get the biggest exponent I could possibly get. Just remember that once you want to check and make sure you can get the most you can possibly get, and you want one of everything. Okay. Yeah, so try and answer the questions, and of course we'll go over them tomorrow in class, so we can clear up any questions you guys have.